You are watching the Wonder Lab. Imagine a universe where every star, every planet, every flicker of light and whisper of sound holds a story. A story so delicate, so faint, that it slips past the ordinary senses of human perception. We live surrounded by energy, light streaming from the sun, the chatter of the cosmos in radio waves, the faint echoes of distant explosions, yet most of it is invisible, inaudible, imperceptible. Today we explore the extraordinary world of the imperceptible. Signals so weak that they are measured in fractions smaller than anything we can naturally sense. Intensities as low as 10 watts, 1510 to 15 watts per square meter. To give it context, sunlight on your skin is about 1,000 watts per square meter. Moonlight? A mere thousandth of that. But what happens when we move trillions of times fainter to a realm almost beyond imagination? In this journey, we will follow scientists into the quietest rooms on Earth, into the farthest reaches of space, and into the extraordinary tools they've built to catch whispers of the universe that are smaller than the flicker of a candle seen from thousands of kilometers away. These signals, almost vanishing, carry the secrets of cosmic events, distant galaxies, and the very structure of reality. This is a story of curiosity, ingenuity, and persistence, of human beings determined to listen when the universe whispers. Welcome to the world of the faintest signal in the universe. The universe speaks, but not always in ways our senses can grasp. Every moment, every second, countless forms of energy pass through the world: light, sound, radiation, gravitational waves. Yet much of it is invisible, inaudible, and almost imperceptible. Today we step into a realm so subtle, so delicate, that the energies we are about to explore are smaller than what our bodies can naturally sense, smaller than the faintest glimmer of moonlight, smaller than the whisper of a sound in an anechoic chamber. These are the faintest signals in the universe. Imagine standing in the middle of a forest at night. The air is still. You hear the rustle of leaves in the wind, a distant owl calling. But beneath these sounds exists another layer of reality, vibrations too faint to hear, radiations too weak to feel. Every star in the sky emits energy that travels for billions of years, and yet, by the time it reaches Earth, it may be as faint as 1510 hertz, 15 watts per square meter. That is a 1/4,000,000th the energy that strikes you from a single light bulb. It is almost nothing, and yet it tells stories older than the Earth itself. Light is our first guide. We know the sun floods our planet with light and warmth, making life possible. But outside the protective cocoon of Earth, space is filled with light that is virtually invisible. Cosmic background radiation, the relic of the Big Bang, streams endlessly across the cosmos, traveling through empty space at unimaginably low intensities. Each photon that reaches our instruments is a tiny messenger, carrying with it a fragment of history. It is a faint whisper from the earliest moments of existence, a whisper that has survived the vast stretches of time and space. Now, consider sound. In our daily life, we are surrounded by noise, the hum of electronics, the chatter of people, the wind against trees. Yet, there exist spaces where sound itself almost disappears. Anechoic chambers, the quietest rooms on Earth, are engineered to absorb every echo, every vibration. Step inside, and the silence can be suffocating. You begin to hear your heartbeat, your breathing, the subtle pulsing of your own blood. Sound waves at levels below 10 to 15, 1.10, aqui ao bordo de 15, 110-15 to WM2, are undetectable to human ears, but sophisticated instruments can measure them with breathtaking precision. In these experiments, we confront the limits of perception itself. What can be observed, what must be inferred, and what remains forever beyond our senses. The human mind, however, is not content to remain in ignorance. Curiosity drives us to invent tools that extend our perception beyond natural limits. LIGO, the Laser Interferometer Gravitational Wave Observatory, listens to the universe in a language almost incomprehensible to ordinary experience. It detects gravitational waves, ripples in the very fabric of space-time caused by colliding black holes or exploding stars. These waves stretch and compress Earth by a fraction of a proton's width. A signal so faint it defies intuition, yet one that reveals truths about the universe we could never otherwise know. The James Webb Space Telescope, orbiting high above Earth, captures photons from galaxies billions of light years away. These photons, each carrying a whisper of information, are often so faint that even the most sensitive human instruments would consider them non-existent. And yet, through meticulous observation and advanced detectors, we can reconstruct images, spectra, and stories of galaxies long extinguished, traces of cosmic history traveling over incomprehensible distances, arriving at our sensors as energies measured in 10, 15, 15 to 2 or less. Even the air around us, invisible yet alive with faint energies, contains messages. Cosmic rays, electromagnetic fluctuations, the subtle influence of magnetic fields, all are forms of energy that pass through us constantly, mostly unnoticed. Instruments like superconducting quantum interference devices and cryogenic sensors detect these energies, revealing the hidden structure of reality. Scientists work patiently, often for years, to measure these almost imperceptible signals, knowing that each one might change our understanding of the universe. The faintest signals also carry a philosophical lesson. They remind us that the universe is vast, and our senses are limited. They challenge the very notion of what it means to observe, to perceive, and to know. In the presence of such subtlety, humans learn patience, ingenuity, and humility. We develop new technologies, refine our methods, and expand the boundaries of science. Each faint signal that is detected is a victory of human curiosity, a testament to our relentless pursuit of knowledge. In the next moments, we will journey deeper into these hidden energies. We will explore the instruments designed to detect the undetectable, the scientists who dedicate their lives to listening to the universe's faintest whispers, and the astonishing discoveries that arise from these subtle signals. From the quietest rooms on Earth to the farthest reaches of the cosmos, we will uncover how the faintest energies illuminate the grand story of existence, showing that even in the realm of the almost invisible, there is wonder, there is discovery, and there is truth. In the vast silence of space and the hidden depths of human perception, faint signals exist constantly, waiting for us to notice. Yet to see what is almost invisible, to hear what is imperceptible, humanity must invent tools far beyond the ordinary. In this part of our journey, we will explore these extraordinary instruments, machines so precise, so sensitive, that they can detect the faintest whispers of the universe. Let us begin on Earth, in the quietest places ever constructed by human hands. Anechoic chambers, sometimes called the quietest rooms on Earth, are designed to absorb every echo, every reflection of sound. Step inside one of these chambers and you might think you have entered an empty void. There's no echo, no background noise, no hum of electricity. The silence is absolute, so profound that the human ear begins to hear things normally drowned out. Your heartbeat, the flow of blood, the subtle movements of air in the room. Sound waves at intensities below 1015 minus 10, 15, pass through the room unnoticed by our senses. Yet sensors inside the chamber can detect them with astonishing precision. These chambers are not mere curiosities. They are laboratories where researchers explore the limits of human perception, the physics of sound, and the behavior of materials in extreme silence. By measuring vibrations that are nearly non-existent, scientists can test microphones, calibrate acoustic equipment, and even study human reactions to near-perfect quiet. It is here that we begin to understand the extraordinary sensitivity required to detect faint signals, a sensitivity mirrored in the instruments used to study the universe itself. Now, let us leave the quiet of Earth and move to the cosmic frontier. Here, signals are faint, not because of silence, but because of distance. Gravitational waves, ripples in the fabric of spacetime, are emitted by catastrophic events like black hole mergers and supernovae. Yet, by the time they reach Earth, these waves have stretched and compressed the planet by a distance smaller than a single proton. Detecting such a signal requires technology that borders on the miraculous. Enter LIGO, the Laser Interferometer Gravitational Wave Observatory. Spanning kilometers, LIGO uses lasers to measure changes in distance with unimaginable accuracy. A laser beam travels down a long corridor, bounces off mirrors, and returns to its origin. If a gravitational wave passes, the distance changes by less than a fraction of a proton's width. A tiny shift imperceptible to human senses. But computers and sensors detect this change, converting it into data that scientists can interpret. The faint signal, once invisible, is now a revelation, the echo of colliding black holes, the whisper of cosmic events billions of light years away. Beyond gravitational waves, the faint light of distant galaxies challenges even our most advanced telescopes. The James Webb Space Telescope peers into the deep cosmos, capturing photons that have traveled for billions of years. These photons arrive at Earth's orbit as faint as 10-15 Wm, carrying with them the story of galaxies long extinguished. The telescope's mirrors, cooled to near absolute zero, prevent any heat from interfering with the detection of these photons. Its instruments are designed to capture light at the faintest levels, transforming almost invisible signals into vivid images and spectra that reveal the universe's history. Radio astronomy, too, confronts faint signals. The WOW signal, detected in 1977, lasted only 72 seconds, yet it remains one of the most mysterious events in astronomy. It was a faint signal, barely distinguishable from the background noise of space, captured by a sensitive radio telescope. Even decades later, scientists study the faintest echoes of this signal, searching for clues about distant cosmic phenomena. Each faint blip in the data could hold the key to understanding a galaxy, a star, or perhaps even life beyond our planet. These instruments, whether anechoic chambers, gravitational wave detectors, space telescopes, or radio antennas, share a common principle. They extend human perception beyond its natural limits. They measure energies so faint that ordinary instruments would ignore them, so small that human senses cannot detect them, and yet they carry information of extraordinary significance. In laboratories around the world, scientists calibrate these instruments meticulously. Lasers are aligned with precision beyond comprehension. Mirrors are polished to perfection. Sensors are cooled to fractions of a degree above absolute zero. Every precaution is taken to ensure that when the faintest signal arrives, it is not lost, not drowned in noise, not mistaken for background interference. The universe does not announce itself loudly. It whispers, and we must listen with tools crafted for listening. Even on Earth, ambient energy from the environment can overwhelm faint signals. Cosmic rays, electrical noise, and even the subtle vibrations of the building itself can mask what researchers seek. Techniques such as shielding, isolation, and digital filtering are essential. Scientists create controlled environments where the faintest energy can be distinguished from the surrounding chaos. It is a battle against invisibility, a confrontation with the subtlety of nature itself. Through these efforts, the imperceptible becomes perceptible. A faint signal in the data may reveal a previously unknown star, a distant galaxy, or the collision of massive cosmic objects. Each detection is a triumph of patience, ingenuity, and curiosity. And yet, for every signal captured, countless others remain undetected, awaiting instruments of even greater sensitivity. This is the world of the faintest signals, a realm where human creativity meets the limits of perception, where the universe speaks in whispers, and we have built ears that can hear them. As we continue our journey, we will explore even more astonishing examples, from the detection of single photons in space to quantum sensors on Earth. And we will uncover how these faint signals illuminate the hidden truths of our cosmos. As we leave the confines of laboratories and observatories, we step into the vast expanse of space, a realm where signals are not only faint, but almost unimaginable in their subtlety. Here, energy travels across billions of light years, arriving at Earth as whispers rather than shouts. It is a universe speaking in the smallest increments, and it is through these faint signals that the cosmos tells its story. The first whispers we will encounter are those of light. Every photon of light that reaches our telescopes carries a message, a story of a star born billions of years ago, a galaxy forming its first clusters, a cosmic explosion unfolding in the farthest reaches of space. These photons arrive at Earth with an intensity so weak that it can be measured only in units like 10 to 15 to mensu den 10 to 6 cast to 15 guess you mem 210 to 15 to do m2 cus. Yet, each one holds invaluable information. By capturing and analyzing these tiny fragments of energy, astronomers can reconstruct the life cycle of stars, the growth of galaxies, and even the chemical composition of distant worlds. Consider the James Webb Space Telescope, a marvel of human engineering designed to capture the faintest glimmers of light. Its mirrors, spanning over 6 meters in diameter, are polished to perfection, cooled to near absolute zero to avoid interference from its own heat, and equipped with sensors capable of detecting individual photons. With these tools, astronomers have observed galaxies so distant that their light began its journey billions of years before Earth even existed. Each photon arriving at the telescope represents a whisper from the past, a message traversing both time and space to reach us. But faint signals are not limited to light. Radio astronomy reveals the cosmos in a frequency invisible to the naked eye. One of the most intriguing events ever recorded in this spectrum was the WOW signal, detected in 1977. For just 72 seconds, a radio telescope in Ohio picked up a mysterious signal originating from the constellation Sagittarius. The intensity was barely above the background noise, yet it stood out, capturing the imagination of scientists and the public alike. To this day, the WOW signal remains unexplained, a faint murmur from the universe hinting at possibilities beyond our understanding. Gravitational waves, too, offer a profound example of cosmic whispers. These ripples in spacetime, caused by cataclysmic events such as black hole mergers and neutron-star collisions, are imperceptible to human senses. LIGO, the Laser Interferometer Gravitational Wave Observatory, detected its first gravitational wave in 2015, a signal originating from a pair of black holes colliding over 1 billion light-years away. The wave stretched and compressed Earth by a distance smaller than a proton, a shift so subtle it could have gone unnoticed without highly specialized equipment. Yet, from this tiny signal, scientists learned about the existence, mass, and spin of black holes, phenomena that would otherwise remain invisible. Faint signals also reveal the structure of the universe itself. Cosmic microwave background radiation, the residual heat from the Big Bang, permeates space at an almost imperceptible level. Detected at intensities close to 10 to 15 WAMPs 10, 15 WAM to 10, 15 WAMP, it provides a snapshot of the early universe, offering insights into its expansion, the distribution of matter, and the seeds of galaxies. Through this subtle radiation, we can trace the evolution of the cosmos from its earliest moments to the vast, complex structures we see today. The pursuit of faint signals is not only a technical challenge, but a philosophical one. It demands patience, precision, and humility. Scientists must distinguish meaningful information from noise, sift through mountains of data, and consider the possibility of error at every step. Yet every faint signal detected is a triumph, a small, almost invisible victory that expands our understanding of reality. It reminds us that the universe communicates in whispers and that human ingenuity allows us to listen. On Earth, researchers continue to refine their instruments, pushing the boundaries of sensitivity. Quantum sensors, superconducting detectors, and cryogenic instruments are developed to perceive energies smaller than a single photon. Vibrations weaker than the faintest sound, and fields too subtle to measure by conventional means. Each technological advance brings previously hidden aspects of the universe into view, revealing patterns and structures that challenge and inspire our imagination. The faintest signals are also a testament to collaboration. Scientists across the globe share data, cross-verify observations, and coordinate experiments to ensure that what is detected is real and significant. From Antarctica's radio observatories to orbiting space telescopes, from underground gravitational wave detectors to the quietest labs on Earth, humanity's collective effort allows us to perceive the universe in ways that were once thought impossible. Yet, even as we uncover these cosmic whispers, the universe retains its mysteries. Signals remain faint, fleeting, and often incomprehensible. For every discovery, countless others await, messages traveling across unimaginable distances hidden in the darkness, nearly imperceptible to even our most advanced instruments. And it is in the pursuit of these signals, in the patient listening and careful observation, that the spirit of discovery thrives. This is the story of faint signals, a story of light and sound, of gravitational waves and cosmic radiation, of human ingenuity and perseverance. It is a story that teaches us patience, humility, and the extraordinary power of curiosity. Even in the realm of the almost invisible, the universe is alive with information, waiting for those who are willing to listen. As we continue our journey into the faintest signals, we find ourselves not only observing phenomena far beyond human perception, but also confronting the limits of our own understanding. These subtle energies, photons from distant galaxies, vibrations in the fabric of space-time, signals at the edge of detectability, challenge what it means to know, to sense, and to discover. They remind us that the universe communicates in ways that are often invisible, imperceptible, and profoundly delicate. On Earth, we encounter faint phenomena that mirror the subtlety of cosmic signals. In the quietest laboratories, sound waves below 10, 15 WS, MEM 210, 15, M 210, 15 WM2 ripple through the air, undetectable to the human ear, yet precisely measurable by sensitive instruments. Researchers step into anechoic chambers, feeling the oppressive stillness that is almost alien to human perception. Here, they learn to observe patience, to measure with extraordinary accuracy, and to distinguish between what is real and what is noise. The lessons learned in these controlled environments inform the technologies that allow us to perceive the universe itself. Consider For a moment, the faintest of vibrations traveling through the Earth's crust. Seismographs can detect earthquakes from thousands of kilometers away, yet they can also measure tremors so subtle they are caused by nothing more than ocean waves or distant human activity. The same principle applies in astrophysics. Every faint signal tells a story, whether it is the collapse of a distant star or the whisper of gravitational waves from a merging black hole. The ability to detect such minute events requires not only technology but also ingenuity, patience, and imagination. The implications of these faint signals extend beyond science. They affect how we perceive our place in the cosmos. Each faint photon captured by a telescope is a message from the past, revealing the life and death of stars, the formation of galaxies, and the evolution of the universe. Gravitational waves convey events so violent and distant that they would otherwise remain invisible, yet they arrive on Earth as imperceptible ripples, transforming our understanding of reality. Even the fleeting radio signals, like the "wow" signal, remind us of the vast mysteries that remain hidden, urging us to explore further. The pursuit of the almost imperceptible reshapes human perspective. We learn humility in the face of vast distances and cosmic timescales. We develop patience in experiments that may take years or even decades to yield results. And we cultivate curiosity, driven by the knowledge that even the faintest signal may contain a revelation capable of transforming our understanding of the universe. Technological advances continue to push the boundaries of detection. Quantum sensors measure fluctuations smaller than a single photon. Cryogenic instruments detect energies almost impossible to perceive. Superconducting detectors capture signals that would otherwise vanish into the background. These innovations, born from necessity and guided by imagination, allow humanity to perceive the faintest whispers of existence. Moreover, the faintest signals remind us that observation is a collaborative endeavor. Scientists, engineers, and researchers around the world share data, cross-verify findings, and refine their instruments to ensure accuracy. From the isolated deserts of Chile to underground gravitational wave facilities, from space-based telescopes to laboratories at the cutting edge of physics, the pursuit of faint signals is a testament to human cooperation, dedication, and ingenuity. Yet, even as we uncover these subtle phenomena, the universe retains its mysteries. Signals remain fleeting, vanishing almost as quickly as they appear. Background noise threatens to overwhelm them, and the smallest error can obscure a message entirely. It is this challenge, the tension between the imperceptible and the detectable, that fuels the wonder and excitement of discovery. Each faint signal that emerges from the noise is a triumph, a victory of curiosity over limitation. In reflecting on the human perspective, we realize that the faintest signals are not merely scientific curiosities. They are reminders of our capacity to perceive, to imagine, and to understand. They teach us that even when something seems beyond our reach, with patience, ingenuity, and technology, we can uncover truths hidden in the subtlest details. They inspire us to explore further, listen more closely, and continue the pursuit of knowledge. As we conclude this part of our journey, let us consider the broader implications. Faint signals connect us to the universe in ways we never thought possible. They reveal the life cycles of stars, the structure of galaxies, the echoes of gravitational waves, and the remnants of the Big Bang. They expand our understanding, deepen our curiosity, and humble us before the vastness of existence. This is the realm of the almost imperceptible, a domain where energy is subtle, signals are faint, and discoveries require extraordinary care. Yet within this realm lies wonder, insight, and a profound connection to the cosmos. The faintest signals are not silent. They speak to those who listen, revealing the universe in whispers, guiding humanity toward knowledge, understanding, and awe. As we continue our journey into the faintest signals, we begin to uncover phenomena of the universe that are not merely faint, but extraordinarily extreme. These are events and energies that shape the cosmos, yet arrive at Earth as whispers, almost imperceptible traces of colossal forces operating across unimaginable distances and timescales. Consider a supernova, the explosive death of a massive star. In the heart of a galaxy, such an event releases more energy in a single moment than our sun will emit over its entire lifetime. And yet, when the light and radiation from that supernova reach Earth, often billions of light years away, the energy per square meter is vanishingly small, sometimes as low as 10 to 15 Wm, 10 on the bues, kemers Wm the themno am kender de wembor. 2. Each photon carries a fragment of this enormous story, traveling across the vast cosmic void to arrive as a faint signal detectable only by our most sensitive instruments. Gravitational waves, too, illustrate this paradox. When two black holes merge, the resulting ripples in spacetime are immense in origin, yet by the time they reach Earth, the disturbance is smaller than a fraction of a proton's width. Detectors like LIGO and Virgo measure these fluctuations with extreme precision. Every detection transforms a barely perceptible vibration into knowledge of some of the most powerful events in the universe. We witness the collision of objects so massive they warp space-time itself. Yet the signals arrive as gentle ripples, a cosmic whisper made visible through human ingenuity. In the realm of light, the faint glow of distant galaxies tells stories of formation, collision, and transformation. The photons arriving from these galaxies have traveled billions of years, often passing through cosmic dust, gas clouds, and interstellar space. Despite the immense journey, instruments like the James Webb Space Telescope, Hubble Space Telescope, and powerful ground-based observatories capture these signals with astonishing clarity. The faintest light becomes a messenger, illuminating the history of cosmic evolution and revealing secrets about the earliest stars, the growth of galaxies, and the distribution of matter across the universe. But faint signals are not only cosmic in scale. Even on Earth, energies too subtle for ordinary perception influence the physical world. Quantum fluctuations, subatomic vibrations, and low-level electromagnetic waves exist constantly, often unnoticed. Scientists have designed experiments capable of detecting single photons, minute magnetic field variations, and thermal changes smaller than a billionth of a degree. These investigations reveal the hidden structure of reality, showing that the universe is alive with activity even where we perceive stillness. The wow signal captured in 1977 remains a profound example of the universe's subtle communication. For just 72 seconds, a radio telescope detected a signal that briefly emerged from the cosmic background. The intensity was nearly imperceptible, yet it stood out against the noise, a fleeting message that sparks curiosity and speculation decades later. It reminds us that faint signals are not always weak in significance. Their implications can be profound, and their mysteries enduring. Every faint signal, whether light, sound, radiation, or gravitational wave, is part of a delicate cosmic conversation. They teach us that observation requires patience and care, that the universe communicates not in forceful proclamations, but in subtleties. It is in listening carefully, in refining our instruments and methods, that we gain insight into phenomena beyond ordinary comprehension. The pursuit of these signals also highlights human ingenuity. Researchers design complex sensors, align mirrors to nanometer precision, and isolate instruments from the faintest vibrations. Cryogenic cooling reduces thermal noise to near absolute zero. Quantum detectors reveal energies previously thought undetectable. Each advance pushes the boundary between the imperceptible and the measurable, turning whispers into understanding. Moreover, the faintest signals illuminate connections between phenomena that appear unrelated. The collision of black holes, the glow of distant galaxies, the faint hum of cosmic background radiation, and the subtlest vibrations on Earth all obey the same laws of physics. By detecting these signals, scientists can trace patterns, test theories, and predict behaviors across scales unimaginable in human terms. The faint signals are the universe's fingerprints, revealing its order and its secrets. Yet, for all our achievements, the faintest signals remind us of our limitations. Most remain undetected. Most pass through space and matter without leaving a trace discernible to any instrument. The universe is not obliged to announce itself loudly, and its subtleties challenge our imagination, our patience, and our technology. It is in this struggle to detect, measure, and understand that the wonder of science thrives. As we observe the extreme events that give rise to faint signals, we learn humility. We realize that even phenomena of unimaginable magnitude, exploding stars, merging black holes, distant galaxies, can arrive as nearly invisible whispers. And yet, through ingenuity, perseverance, and curiosity, humanity has learned to listen, to interpret, and to understand. These signals are not merely measurements. They are the universe speaking directly to us, inviting us to comprehend the profound and the subtle. In this way, the faintest signals are a bridge between the imperceptible and the understood, the enormous and the subtle, the distant past and the present. They remind us that knowledge begins not with certainty, but with observation, patience, and imagination. The universe, in its quietest moments, is always communicating, and through the pursuit of faint signals, we have learned to hear. In the universe, not everything shouts to be heard. Much of reality communicates in whispers, in signals so subtle that they pass unnoticed unless we have the tools, patience, and curiosity to detect them. These faint energies, whether in the form of light, gravitational waves, radiation, or subatomic vibrations, carry profound information about the structure, history, and dynamics of the cosmos. Today we explore the frontiers where the imperceptible meets discovery, where faint signals reveal truths beyond ordinary perception. Consider the photons arriving from distant galaxies. Each particle is small, almost negligible, yet collectively they map the structure of the universe. By capturing light that has traveled billions of years, astronomers reconstruct cosmic history, star formation, galactic evolution, and the chemical processes that lead to planets and perhaps life itself. The faintest glimmers, measured in intensities as low as 10 to 15 inform us about epochs we can never physically visit, and events that occurred long before Earth existed. Gravitational waves provide another extraordinary example. When black holes collide, the event itself is cataclysmic, yet by the time its effect reaches Earth, it manifests as a ripple smaller than a proton's width. Instruments like LIGO and Virgo transform these imperceptible distortions into meaningful data. Every detection informs us about the masses, spins, and distances of these black holes, revealing phenomena that challenge our imagination. The faint signals are tiny windows into the most violent and energetic processes in the universe, captured through human ingenuity and technological excellence. Even the most subtle background energies in the universe carry lessons. Cosmic microwave background radiation, the echo of the Big Bang, arrives at Earth as a whisper of energy. Measuring these faint signals allows cosmologists to determine the age of the universe, map its expansion, and explore the distribution of matter and dark energy. These are energies almost impossible to perceive with unaided senses, yet they define the framework of reality itself. On Earth, the pursuit of the imperceptible continues at the quantum level. Researchers measure phenomena such as single photon emissions, ultra-low-level magnetic fields, and quantum fluctuations. Cryogenic sensors, superconducting detectors, and quantum interference devices allow us to detect energies and vibrations previously thought to be beyond measurement. Each discovery reveals hidden patterns in nature, connecting the smallest scales with the grandest cosmic structures. These faint energies are not only scientific tools, they shape our understanding of existence. They force us to redefine what we consider observable, to rethink the limits of perception, and to acknowledge the vastness of what remains hidden. By studying the imperceptible, humans learn humility, the recognition that the universe operates on scales and intensities that challenge our ordinary intuition. Instruments and experiments dedicated to faint signals also highlight human ingenuity and creativity. Engineers and scientists must account for the smallest sources of noise: thermal vibrations, cosmic rays, seismic activity, and electromagnetic interference. By isolating instruments, cooling sensors, and employing sophisticated algorithms, they transform almost imperceptible signals into rich, meaningful data. The faintest energies, once invisible, become windows into the workings of the cosmos. Consider the wow signal again, brief, faint, and mysterious. Its near imperceptibility reminds us that even fleeting signals can spark immense curiosity, inspiring generations of researchers to develop instruments capable of capturing what was previously undetectable. The universe is not only vast, it is subtle, layered with information that requires patience, focus, and creativity to uncover. The faintest signals also teach us about interconnectedness. The vibrations of spacetime, photons from distant galaxies, cosmic rays, and quantum fluctuations all operate under the same physical laws. By detecting and interpreting these signals, scientists connect phenomena across scales, from subatomic particles to galactic superclusters, from minuscule local effects to cosmic history. The universe, though seemingly silent in many ways, communicates a coherent story through its faint energies. Beyond the science lies philosophy. What does it mean to observe, to measure, to comprehend? Faint signals challenge us to recognize that knowledge often begins in imperceptibility. That understanding requires patience, ingenuity, and imagination. That discovery is not about loud proclamations, but subtle revelations. The universe does not always make itself obvious. It offers hints, whispers, and traces, waiting for those attentive enough to perceive them. As we conclude this part of our exploration, it is clear that the faintest energies, photons, gravitational waves, subatomic vibrations, and cosmic radiation are not merely scientific curiosities. They are the threads that weave the tapestry of the cosmos. They reveal the dynamics of distant galaxies, the violent collisions of black holes, the birth and death of stars, and the echoes of the universe's beginning. By studying these faint signals, humanity extends its senses, understanding, and imagination far beyond the limitations of natural perception. This is the realm where the imperceptible becomes perceptible, where patience and ingenuity meet cosmic subtlety. The universe speaks in whispers, and we, with our instruments, our curiosity, and our perseverance, have learned to listen. These faint energies, almost invisible yet profoundly meaningful, illuminate the invisible structure of reality, guiding us toward knowledge, insight, and awe. As we venture deeper into the universe of faint signals, we encounter phenomena so subtle, so mysterious, that their very existence challenges human perception. These are the signals that speak quietly but profoundly, messages hidden within the cosmic noise, patterns in the darkness, whispers that traverse billions of years to reach us. Consider pulsars, the rapidly spinning remnants of massive stars. Each rotation emits a precise pulse of radio waves, so faint that without sensitive instruments they would be entirely imperceptible. These pulses are clocks of the cosmos, steady and unwavering, revealing the presence of exotic matter, gravitational effects, and even the intricate structure of our galaxy. By studying these faint rhythmic signals, scientists uncover patterns in the universe that are invisible to the naked eye, connecting time, space, and energy in astonishing ways. Beyond pulsars, the cosmic microwave background radiation offers another window into hidden patterns. Subtle fluctuations in this nearly uniform glow reveal the seeds of galaxy formation, the large-scale structure of the universe, and the distribution of dark matter and dark energy. These signals, measured in intensities often below 10-15 W210 radiofonds versus 210-15 are faint yet rich with information, a delicate map of the universe's infancy. Etched across the heavens, gravitational waves continue to reveal the invisible choreography of the cosmos. When massive objects collide, they ripple space-time itself, creating signals that propagate silently across billions of light years. Each detection adds a new chapter to our understanding, the history of black holes, the dynamics of neutron stars, and the subtle interactions shaping galaxies. The signals are faint, fleeting, yet immensely informative, whispers of events so distant and powerful that we can only perceive them through ingenuity and sensitive instrumentation. On Earth, scientists push the limits of detection even further. Quantum sensors, superconducting devices, and cryogenic instruments measure energy smaller than a single photon. Fluctuations too slight for ordinary measurement, vibrations almost imperceptible to the most advanced equipment. Each faint observation reveals hidden layers of reality, connecting phenomena across scales from subatomic particles to the largest structures in the universe. The faintest signals are bridges, linking the microcosm with the macrocosm, the imperceptible with the observable. Even the faintest radio signals from deep space, like the wow signal, continue to puzzle and inspire. Though brief and subtle, they challenge our understanding of the cosmos and compel us to develop ever more sensitive instruments. Each faint signal is a question posed by the universe, inviting us to listen, to observe, and to imagine possibilities beyond what we can currently detect. The study of faint signals is not merely technical. It is philosophical. It reminds us that knowledge begins where perception ends, that the universe communicates in subtleties, and that curiosity and ingenuity are essential to uncovering the truth. It teaches patience, humility, and imagination, qualities necessary to interpret signals that are almost invisible, yet profoundly meaningful. Through these observations, hidden patterns emerge. Galaxies align in vast cosmic filaments, clusters form intricate webs, and gravitational interactions leave traces detectable only through the faintest energies. By following these patterns, scientists reveal the underlying order of the cosmos, a structure that is both complex and elegant, subtle yet immensely informative. Human ingenuity transforms the imperceptible into discovery. Instruments measure vibrations smaller than a proton, capture single photons traveling across billions of light years, and detect gravitational waves from cataclysmic events billions of years in the past. These feats require meticulous planning, precision engineering, and decades of collaborative research. The faintest signals, once invisible, now guide humanity's understanding of the universe, illuminating connections that were previously unimaginable. As we conclude this part of our journey, we see that the universe is alive with faint energies, subtle signals, and hidden patterns. They teach us that discovery does not always arrive as a roar. Often it comes as a whisper, a fleeting trace, a subtle hint of the extraordinary. And it is through listening, observing, and interpreting these faint phenomena that we glimpse the full grandeur of the cosmos. The faintest signals are ultimately an invitation to perceive beyond the obvious, to measure beyond the ordinary, and to understand beyond the immediately visible. They remind us that the universe, in all its vastness, communicates continuously, and that human curiosity, patience, and ingenuity allow us to respond. These whispers, the faint signals of light, sound, radiation, and space-time, are the universe's most subtle messages. And through them we learn not only about the cosmos, but also about ourselves, our creativity, our perseverance, and our capacity to listen to the nearly invisible truths of existence. As we progress deeper into the realm of faint signals, we confront the universe in its most subtle and enigmatic form. Here, energies are so delicate that they pass unnoticed, yet they carry profound truths about the cosmos. These signals, from the faintest photons to the tiniest space-time ripples, reveal layers of reality that challenge human imagination, patience, and ingenuity. Imagine light traveling billions of years, arriving as a barely detectable glow, whispering stories of stars long extinct and galaxies long formed. Each photon is a messenger, a fragment of history. By capturing these delicate signals, scientists reconstruct cosmic events, unraveling the origins of stars, planets, and galaxies. Even the faintest radiation from the cosmic microwave background provides insights into the birth of the universe, revealing patterns that formed when time itself was young. Gravitational waves illustrate another dimension of subtlety. Massive events, black hole collisions, neutron-star mergers, create ripples in space-time so faint that, upon reaching Earth, they distort distances smaller than a fraction of a proton. Observatories like LIGO and Virgo detect these minute perturbations, converting imperceptible vibrations into data that expands our understanding of the cosmos. Each detection is a revelation, a quiet note in the symphony of the universe. Yet, the universe is not limited to phenomena detectable by current instruments. Quantum fluctuations, dark matter interactions, and other unseen energies permeate reality. They shape galaxies, influence cosmic evolution, and remain largely mysterious. Scientists design experiments at the cutting edge of technology, quantum sensors, superconducting devices, cryogenic detectors, to capture even the faintest of these phenomena. Each faint signal measured provides a glimpse into the architecture of existence itself. Even on Earth, the faintest energies are meaningful. Subatomic vibrations, low-level electromagnetic fields, and minor thermal changes occur continuously, imperceptible to human senses. But in laboratories worldwide, researchers detect and study these phenomena, connecting them to broader cosmic patterns. The faint and the immense, the microscopic and the galactic, are intertwined in a delicate web of energy and information. The philosophical implications of these faint signals are profound. They remind us that the universe does not always communicate loudly. Knowledge begins where perception ends, in the subtle traces and whispers that we must learn to interpret. These energies challenge assumptions, spark curiosity, and demand ingenuity. They teach patience, humility, and wonder. Consider fleeting radio signals such as the wow signal, which lasted mere seconds but continues to captivate decades later. Its faintness underscores the delicacy of observation and the necessity of attentiveness. It is a cosmic hint that even a brief, imperceptible signal can hold immense significance, guiding scientists toward new discoveries and inspiring generations to improve detection methods. Hidden patterns emerge from these faint energies. Cosmic filaments, pulsar rotations, gravitational waves, and minute quantum fluctuations reveal a universe structured by subtle rules and interconnections. By observing these faint phenomena, scientists uncover relationships that span scales, from subatomic particles to galactic superclusters. The universe communicates not only through explosions and bright flashes, but also through its whispers, the delicate interconnections that form the hidden architecture of reality. Human ingenuity transforms these faint signals into understanding. Instruments measure vibrations, smaller than a proton, detect single photons, and capture ripples in spacetime across billions of light years. Experiments are conducted with extreme precision, shielding instruments from even the faintest environmental noise. Each technological advance converts imperceptibility into discovery, showing that observation is as much about creativity as it is about measurement. Through faint signals, the universe teaches us to listen beyond the obvious. It invites us to perceive patterns, to detect whispers, and to interpret subtle phenomena. The smallest energies often have the largest implications, revealing truths about the origins of galaxies, the behavior of black holes, the nature of matter, and the fabric of space-time itself. These are the signals that inform theories, shape experiments, and inspire imagination. As we conclude this part of our journey, it is clear that the faintest signals, photons, gravitational waves, quantum vibrations, cosmic radiation, are not merely scientific curiosities. They are the threads of reality, weaving together the microcosm and the macrocosm, the imperceptible and the observable. By studying them, humanity expands its understanding, extends its perception, and discovers its place within a vast and subtle cosmos. The universe, in its quietest and most delicate moments, communicates continuously, and through ingenuity, curiosity, and careful observation, we have learned to listen. The faintest energies, once invisible, now illuminate the hidden structure of reality, guiding us toward knowledge, insight, and a profound appreciation of existence. As we reach the penultimate chapter of our exploration into faint signals, we stand at the boundary between observation and understanding, between the imperceptible and the known. The universe communicates constantly, yet much of it whispers, subtle signals that challenge human perception and ingenuity. It is in these whispers that the ultimate secrets of the cosmos reside. Consider the faint glow of distant quasars, luminous cores of galaxies powered by supermassive black holes. The photons that reach Earth have traveled billions of years, passing through clouds of interstellar gas and cosmic dust. By the time they arrive, their intensity is extraordinarily low, faint, almost imperceptible, yet rich with information about the early universe, galaxy formation, and the behavior of matter in extreme gravitational fields. These photons, individually faint, collectively illuminate the vast cosmic history, allowing scientists to reconstruct events that occurred long before Earth itself existed, Gravitational waves reveal the extremes of space-time and motion. Collisions between black holes and neutron stars produce ripples that propagate silently across the universe, detectable on Earth only by instruments of extraordinary precision. Each faint signal contains data about the masses, velocities, and spins of these colossal objects, offering a window into phenomena that are otherwise completely inaccessible. The imperceptible becomes knowledge. The whispers of the cosmos become the language of discovery. On a smaller scale, quantum fluctuations reveal the universe's underlying uncertainty. Subatomic vibrations, zero-point energy, and faint electromagnetic interactions occur constantly, almost invisible to even our most sensitive instruments. Yet, by observing these subtle energies, scientists gain insight into the fundamental rules of nature, the forces that govern everything from the smallest particle to the largest galactic structure. It is here that the faintest signals connect the microcosm with the macrocosm, revealing the coherence of reality across scales, even ephemeral radio signals like the famous wow signal remind us that fleeting whispers can be significant. Though brief, their detection requires precision, patience, and keen attention. They demonstrate that even a momentary trace of energy, imperceptible to ordinary observation, can challenge assumptions, spark new experiments, and inspire generations of inquiry. Each faint signal is a thread in the tapestry of discovery. The synthesis of discoveries from faint signals paints a picture of the universe as a dynamic, interconnected web. Cosmic filaments, star formation patterns, gravitational interactions, quantum phenomena, and faint radiation all operate in concert. By studying these subtle signals, humanity uncovers the hidden structure of reality, revealing relationships that span from the smallest scales of subatomic particles to the largest structures in the observable universe. The faintest energies are not trivial. They are the blueprint of existence itself. Human ingenuity transforms these nearly invisible phenomena into understanding. Advanced instruments measure vibrations smaller than a proton, capture single photons from billions of light years away, and detect the ripples of space-time with unprecedented precision. Cryogenic sensors, superconducting detectors, quantum devices, and space-based observatories allow us to perceive what was once imperceptible. Every faint signal recorded, analyzed, and interpreted expands the frontier of knowledge. Beyond the technical aspects, the faintest signals have philosophical implications. They teach patience and humility, reminding us that the universe communicates subtly and that observation requires care, imagination, and perseverance. They illuminate the delicate interplay between the known and the unknown, the observable and the hidden. They invite reflection on our place in the cosmos, revealing that even the smallest energy, the quietest whisper, can have immense significance. By synthesizing the discoveries of photons, gravitational waves, quantum fluctuations, cosmic radiation, and ephemeral radio signals, we recognize a pattern, a hidden order in the universe's subtle energies. The faintest signals, once overlooked, now guide our understanding of cosmic evolution, matter, energy, and the interplay of forces that shape reality. Each whisper, each subtle vibration contributes to a grand narrative of discovery, connecting phenomena across time and space. As we conclude this part, we realize that the universe is alive with faint energies and imperceptible signals. From the microcosm of quantum vibrations to the macrocosm of colliding black holes and distant quasars, reality communicates continuously, patiently, and subtly. And it is through human curiosity, ingenuity, and perseverance that these whispers are transformed into knowledge, understanding, and awe. The ultimate faint phenomena, from the smallest photon to the largest gravitational ripple remind us that discovery does not always roar. Often it whispers. And through listening, observing, and interpreting these whispers, we glimpse the profound structure of the cosmos, the hidden threads that connect everything, and the extraordinary elegance of the universe in its most delicate form. As we arrive at the final chapter of our journey through the universe of faint signals, it is time to pause and reflect. The cosmos speaks continuously, yet much of its communication is subtle. Faint energies, delicate vibrations, and imperceptible photons convey information across unimaginable distances. These signals, almost invisible, have guided humanity's understanding of the universe, from the tiniest subatomic interactions to the vast choreography of galaxies, the faintest phenomena, photons from distant quasars, gravitational waves rippling through spacetime, quantum fluctuations, cosmic radiation, and transient radio signals together form a tapestry of insight. Each signal, though subtle, carries profound meaning. They allow us to reconstruct cosmic history, trace the life cycles of stars, explore the structure of galaxies, and understand the fundamental laws that govern reality. In the quietest reaches of the universe, discovery unfolds in whispers, not shouts. Human ingenuity has been central to interpreting these whispers. Instruments capable of detecting the imperceptible, cryogenic sensors, superconducting devices, quantum detectors, and space-based observatories have extended our senses far beyond natural perception. Through meticulous observation and creative experimentation, humanity has transformed faint signals into understanding. What was once invisible becomes knowledge. What was almost imperceptible becomes the foundation for cosmic insight. The philosophical implications of these faint signals are as profound as the scientific ones. They remind us that understanding often begins in subtlety, that discovery requires patience, humility, and imagination, that the universe communicates in ways that demand our attention and careful interpretation. These signals teach us that even the quietest whispers can hold truths of immense significance, shaping our perception of existence and our place in the cosmos. Consider the rhythmic pulses of distant pulsars, so precise they rival atomic clocks, or the fleeting wow signal, lasting mere seconds yet inspiring decades of curiosity and experimentation. Think of the photons traveling billions of years to reach us, or the ripples of space-time from colliding black holes that distort distances smaller than a proton. Each of these faint signals is a note in the symphony of the universe, a subtle message from the cosmos, a whisper calling for understanding. Even as we contemplate these signals, the universe continues to speak in subtle ways. Cosmic microwave background radiation maps the early universe. Gravitational waves reveal the dynamics of extreme events, and quantum fluctuations underpin the structure of reality itself. These whispers form a continuous dialogue between the cosmos and humanity, a dialogue that challenges our perception, tests our ingenuity, and rewards our curiosity. Through the pursuit of faint signals, we discover a profound connection between ourselves and the cosmos. The universe, though vast and often imperceptible, becomes accessible through observation, interpretation, and imagination. Every photon captured, every ripple detected, every faint signal recorded is a testament to human perseverance and ingenuity. We learn that even the most delicate phenomena can illuminate the grandest truths. The study of faint signals also reveals the intricate interconnectedness of reality. From the tiniest quantum vibrations to the collision of distant black holes, the universe operates through subtle interactions and hidden patterns. By observing these whispers, scientists uncover the coherence of cosmic structure, the elegance of natural laws, and the extraordinary precision of phenomena across scales. Faint signals, though imperceptible alone, collectively narrate the story of existence. As we draw this exploration to a close, it becomes clear that the universe is alive with information. Every faint signal, photon, vibration, wave, or radiation, is a message waiting to be interpreted. It is through careful observation, ingenuity, and curiosity that humanity can decode these whispers, revealing insights that stretch from the smallest particle to the largest galactic cluster. The imperceptible guides the perceptible. The faint guides the profound. Ultimately, the faintest signals teach us about wonder itself. They remind us that discovery is not always loud, that understanding is often subtle, and that the universe communicates patiently, continuously, and elegantly. By listening to these whispers, humanity participates in a cosmic dialogue, learning not only about the universe, but also about the power of observation, imagination, and curiosity. In the quietest corners of space, in the smallest fluctuations of energy, and in the faintest photons arriving from the distant past, the cosmos speaks. And through our instruments, our minds, and our perseverance, we have learned to listen. The universe, in all its subtlety, is a testament to the beauty of discovery, the elegance of physics, and the unending wonder of existence. And so, as we conclude this journey, remember, the faintest whispers often carry the deepest truths, and in listening we find not only knowledge, but awe. As our journey through the faintest signals and the subtle energies of the universe comes to a close, we pause to reflect on what we have discovered and what remains just beyond perception. From the tiniest vibrations at the quantum scale to the colossal dance of black holes billions of light years away, the universe speaks to us in whispers, almost imperceptible, yet profoundly revealing. Every photon captured from a distant quasar, every gravitational ripple recorded from a cosmic collision, every faint radio signal fleeting across the cosmos is a message not only of matter and energy, but of wonder itself, a reminder that the universe is far richer, far subtler, and far more intricate than our senses alone can perceive. In listening to the imperceptible, humanity discovers humility. We realize that knowledge is not only found in the loud and the visible, but in the quiet traces, the delicate vibrations, the faintest hints that challenge us to look deeper, measure more carefully, and imagine beyond the obvious. These faint signals teach patience, persistence, and the courage to explore the unknown. The universe, in its subtlety, encourages curiosity. It rewards those who pay attention, who refine their instruments, who sharpen their minds, and who embrace the unknown with awe. The faintest energies, once invisible, now illuminate the structure of reality, showing the interconnection between the smallest and the largest, the simplest and the most extreme. Each signal, no matter how faint, carries meaning. Each whisper contributes to the grand symphony of existence. Yet, even as we conclude this journey, the cosmos remains vast, mysterious, and inexhaustibly subtle. For every faint signal we capture, countless others continue undetected, reminding us that discovery is never complete. It is a continuous pursuit, an invitation to observe more carefully, think more deeply, and wonder more profoundly. As we step back from the cosmos, we recognize that faint signals are not just scientific phenomena, they are invitations. Invitations to question, to explore, to connect with the universe in a way that transcends the ordinary. They teach us that the grandeur of existence is often hidden in the delicate, that profound truths may be whispered rather than shouted, and that the art of listening is as essential as the act of observing. And so, as we end this chapter of exploration, remember, the universe is alive with whispers. Every faint signal is a story, every subtle vibration a revelation. Through ingenuity, patience, and curiosity, humanity learns to perceive, interpret, and marvel at the cosmos. The faintest phenomena, almost imperceptible, guide us to the greatest insights. They remind us that the beauty of discovery is not in certainty, but in the wonder of listening, understanding, and imagining. You are watching the Wonder Lab, where the imperceptible becomes knowledge, the faintest whisper becomes revelation, and the universe invites you to wonder without end.